What this piece of equipment is going to show is that when a current flows through a conducting wire, a magnetic field is formed around it. So this piece of equipment has got a wire suspended freely and able to move. It's connected up to our power pack. So the traditional current is going to flow along through the conducting wire and back along through the black wire back to the power pack. On either side, we've got this magnetic field. So when we turn the power on, the conducting wire is going to experience a magnetic field, and that magnetic field is going to repel from the magnets here, and we'll start to see that wire move. So when we turn it on, you're watching to see if the wire moves. And you can see that the magnetic field is interfering with the magnetic field of my permanent magnets, causing it to move. And if we turn the current back off again, you can see that it returns to normal. So this shows to us that this current, when it flows through this wire, produces that magnetic field around it. So how can we increase that magnetic field? Well, that's where the idea of a solenoid comes in. A solenoid is a shaped piece of wire. I'm going to take this and I'm going to wrap it around. Making it this shape increases the strength of the magnetic field, which is strong and uniform. If I connect it up, to my current, we can see if it will manage to pick up. Now, unfortunately, it's not strong enough like this. So we need to see if we can make it even stronger. And the way you do that is by actually forming it around an iron core. Adding an iron core like this increases the strength of the solenoid, and what I've actually formed now is an electromagnet. So if I connect this up, turn our power on, and again we can see. And this time you can see how much stronger it is by the number of paper clips that I've managed to pick up. Now the thing about an electromagnet is it relies on that electricity producing that magnetic field. If I turn the electricity off, the electromagnetism ceases to function. This is useful because it means that you can therefore pick things up when the electricity is on, and when you want to, you can release them by turning the electricity off. Now, we're going to see if we can show you the direction of the current around one of these current carrying wires. So we're going to get rid of this and replacing it with this setup. Over here, you can see I've got my current carrying wire again, running up through. And this time around the top, I've placed these 4 compasses. Compasses. Now currently they're all facing north, over in that direction. But what happens when I turn the current on? So if I put current through this wire, you can see that the compasses all move. And if we look at it now, we can see that they're circling around, because we're producing this magnetic field that moves all the way around like so. So how can we tell which direction they're going? Well, it's as easy as a thumbs up. The thumbs up is actually a great way to determine which way the curve goes. At this moment, my current is running from positive to negative, going from down to up. So my thumb goes up. And you can see here that my fingers are curling around in the same pattern, I'll put it over here, and pointing in the same direction as the compass is. What happens if the current was going the opposite way, going from the positive at the top to the negative at the bottom? Well, doing this, we can now see that my fingers are now pointing this way the opposite direction. So if I turn these over, we should see that it's now facing the opposite direction and going around. So whenever you want to work out which way the current is going around a current carrying wire, just give it a thumbs up.